Hello and welcome to Video Podcast 3.4. The focus of this vodcast is stream erosion, and streams serve as Earth's most important erosional agents. Before discussing sediment transportation, I'd like to restate the definition of erosion. Erosion is the physical removal of a material by a mobile agent, and that mobile agent can be flowing water, waves, wind, and even glacial ice. Our focus is flowing water, because it has the most substantial impact on the reshaping of Earth's surface. A flowing stream is an excellent transporter of sediment, and we're going to focus on three primary rock materials that streams can transport, namely dissolved load, suspended load, and bed load. Dissolved load is invisible, and it's typically going to be delivered by groundwater. Dissolved load will be carried by the stream regardless of the stream velocity. Now, suspended load is material that's actually suspended in water. These are very often clay and silt particles. When you take a look at a river and it looks really muddy, what you're actually seeing is the suspended load. When we consider all three of the types of load on this slide, suspended load is the largest component of sediment that's being transported by a river. Our final consideration is bed load, and bed load is material that might bounce, slide, or roll along the bottom of a river. Bed load can include things like sand, gravel, and even larger rocks and boulders. The tumbling and sliding of bed load along the bottom of a river doesn't occur continuously, although the motion of bed load will be enhanced during times in which the river's velocity increases, say during a flood. Let's talk about meandering rivers, which are rivers that have a lot of curviness to them. If you recall the three zones of a river, most of the erosion occurs in the zone of sediment production, which tends to be towards the headwaters of a river. However, if you take a look at the zone of transportation, which is the zone in which sediment is transported over very long distances, you'll often see channels that have sweeping bends that we call meanders. Your meandering rivers will have very high suspended load. They can often look muddy and murky. They also tend to have deep, smooth channels, because remember, channel roughness drops off pretty drastically as you work your way from the headwaters towards the mouth of a river. Let's take a look at the image at the far right of this slide so that we can develop an understanding of river velocity. For straight sections of a river, the maximum velocity will occur in the dead center of the river. That darker blue region you see in the middle of this image is where the stream is flowing fastest, and as you work your way towards either bank, the river will be flowing at gradually slower speeds. However, things get a little bit different at the curved portions of these meandering rivers. For curved sections of the river, the maximum velocity will occur towards the outside of the curve. And it's towards the outside of that curve that the river possesses the greatest potential to erode the riverbank. If we take a look at the outside portion of this curve and then start working our way back towards the opposite bank, the velocity of the river will decrease substantially as you approach the shoreline depicted here on the right. The focus of this video is erosion, but in the next video we'll talk about deposition. And for curved segments of a river, maximum erosion will take place towards the outside of a curve, whereas deposition will occur towards the inside of the curve. Deposition is when load sinks to the bottom of a river and starts to pile up and accumulate. Over time, the shape of meandering streams can change pretty substantially. Meanders migrate both laterally and downstream, and over time meanders can form things like cutoffs and oxbow lakes. Let's take a look at this picture shown to understand what oxbow lakes are and how they form. In the top image of the geologist sketch, you see a river with pretty significant meandering. If you take a look at the curve shown here and the curve shown here, keep in mind that the maximum stream velocity occurs towards the outside of each one of these curves, and that's where the maximum erosion will be taking place. Over time, as erosion continues on those outer banks, you might reach a point in which a cutoff can form. And a cutoff is basically a shortcut that the river takes once the space in between the two meanders shown has been eroded away. After the formation of a cutoff, what you'll have is an oxbow lake, which is a horseshoe-shaped water structure that's now isolated from the stream. The aerial picture shown from Green River, Wyoming is a great depiction of both a cutoff that had formed and an oxbow lake. When talking about erosion, we also have to mention what's known as base level. Base level is the lower limit to how deep a stream can erode. For major rivers, ultimate base level often occurs at the ocean or in gulfs, but generally speaking, base level will usually occur where a stream enters another body of water. When a stream gets to base level, its velocity and its ability to erode will be greatly reduced. When a river approaches base level, the stream velocity nearly grinds to a halt. And as mentioned previously, the slower a stream's velocity is, the more you'll start to see suspended load fall out of suspension and start to pile up at the bottom of the stream. Now, through engineering, we can change the base level of streams, and we often do this by building dams. In the top image, the ultimate base level for this particular river was at the sea. But let's suppose a dam was built. The new base level for the river will be the water reservoir level shown here. When we change the base level of rivers, the profile of the stream will also be changed, because we'll start to see the deposition of sediment in places that there was no deposition previously. The final thing I'd like to talk about in this particular vodcast are V-shaped valleys. The focus of our conversation thus far has been on meandering rivers. And in terms of river zones, you tend to find meandering rivers in the zone of transportation. However, in the zone of sediment production, where the stream gradient tends to be very steep, we often see V-shaped valleys. V-shaped valleys are often formed by downcutting. You can imagine the water in this picture knifing deeper and deeper into this valley to form that really distinct V-shape. Your V-shaped valleys will often contain things like whitewater rapids and waterfalls. Generally speaking, you won't find whitewater rapids and waterfalls in meandering sections of a river. And as previously mentioned, V-shaped valleys will have very steep gradients, and the river channel will be significantly higher than base level. Okay, that's the conclusion of this vodcast. The focus of this vodcast was stream erosion. And erosion can be thought of as the removal and relocation of material like rocks and sediment. In our next vodcast, we'll talk about stream deposition. And deposition can be thought of as the settling of sediment.